Hi there and welcome to CodeFramer. In this video, I will explain to you about memory management in Python. This is an extremely important topic which will help you a lot during interviews. Also in general as a developer, it is vital to understand how the memory is utilized and managed by Python. Pay complete attention to understand this topic. Let us begin. In Python, everything is an object. Which means, when we create a variable, a, and assign a value of 20 to the variable, then the value 20 is stored in the memory as an integer object, and the value in the memory will be assigned to a variable called a. So if you print the variable a with the type function, then it will give you an integer object as the output. Similarly, if you store an integer value of 50 in variable b, then again value 50, which is an integer object, will be stored in the memory, and it will be referenced to a variable named b. This is how the memory is allocated for the values stored in variables. Similarly, you can store values in variables with other data types, for example, string, float, boolean, etc. But always remember that the memory will be allocated to the value based on the data type object, and it will be later referenced to the variable name. Now let us dig inside this concept a little further. For example, we currently have variable a assigned with the value 20. So if we write a equals c, in this case, what do you think? Whether a new memory location will be created for c? The answer is no. As the value 20 already exists in the memory, this value will be referenced to c. So now, the value 20 will be referenced to both the variable names, which is a and c. Due to this, memory consumption is optimized in Python. I hope that this is clear. So now, if you compare the memory location of a and c, then as you can see, both are pointing to the same memory address. This is because, and as I mentioned earlier, both the variables are pointing to the same integer objects stored in the memory. Now let us try out a few more things. What if we add 1 to the variable c? Now the value of c will become 21. This would mean that another integer object, 21, will be created in the memory, and now this newly created integer object will point to the variable name c. Also remember that the reference between the value 20 and c will be broken. So now, if we try to fetch the memory addresses of the variable a and c with the id function, then as you can see, that memory addresses are different now. Because both the variables are now pointing to different values, stored at different memory locations. I hope that this is clear. Now if we create another variable, d, and assign the value 20, then do you think a new memory location will be allocated to this variable? Again the answer is no. As the integer object, 20, already exists in the memory, Python will simply create a new reference to this variable name, which is d. This is extremely memory efficient if you think about it. So whenever you create any new variable, and assign it with a value, then Python will always check if the memory already has the value. If yes, then it will simply create a reference to the variable name. If not, then it will create the value object in memory and then create a reference. Later when the value of the variable, d, is changed to some other object, say for example, a class object, then immediately a new object will be created in memory with reference to the variable name. This is why Python is known as a dynamically typed language, where the memory allocation of values are dynamic in nature. I hope that this is clear. Now let us move forward and further dig into memory management. So as you know, that your computer OS shares the system memory across different processes, applications and tasks getting executed. Similarly, the OS allocates some amount of memory to the Python interpreter as well. The allocation of memory to the Python interpreter by the OS depends upon the Python version installed, operating system, and the environment settings. So let us say, your installed Python memory is available over the operating system memory. Now the Python memory is divided into two parts, one is called the stack memory, and the other is called heap memory. Now let us understand what is stack memory and heap memory. The stack memory executes all the code blocks like functions, classes, or any line of code written on a Python source code. On the other hand, all the memory allocation is done in the heap memory. So say for example, if you have created a variable, a, and assigned it with value 10. Then the value, which is an integer object, will get created into the heap memory, and the reference of that object, which is a, will be stored in the stack memory. Always remember that the Python execution starts from the main method in the stack memory. Which means that whenever you execute a Python source code, the stack memory will create a main method, and then it will start the execution of the source code from the main method in the stack memory. I hope that this is clear. Let us move forward. Say for example, we created a function called fun1, which accepts a as the argument. And we are invoking that function as b equals fun1, and we are passing the argument as a. When this code is executed, then a new stack is created in the stack memory for function1. And now the state of variables a and b will be maintained in the main stack, and the state of function1 will be maintained in function1 stack. Since we are adding a with 10 inside the function1, a new reference object will be created in function1 stack with the name c, and a new value will be created in the heap memory, which will have the value of integer object 20. In the next line, function2 is invoked, which accepts variable c as an argument, which is referenced to variable d, due to which the state of variable d will be maintained in function1 stack, and a new stack will be created for function2. Now the function2 adds 5 to the input argument, which means that a new value will be created in the heap memory as integer object 25, and it will be referenced to the variable e in the function2 stack. On completion of function2 execution, returned value is handed over to variable d in the function1 stack. Now the stack frame for function2 is no more required, and it is removed from the stack memory. Similarly, when the function1 execution is completed, then function1 stack will no longer be required, and it will be removed from the stack memory. Now only the main stack is left. In the main stack, the integer object 25 will be returned to the variable b, and once the code is executed in the main stack, it will no longer be required, and the main stack will also be removed. But before that, notice here that the value 20 is no longer referenced to any variable in the stack memory. Such values in the heap memory, which are not referenced to any variable in the stack memory, are known as dead objects. The moment the Python interpreter finds that a dead object exists in the heap memory, it will immediately invoke the garbage collector. The garbage collector will then remove the integer object 20 from the heap memory. This type of garbage collector algorithm is called reference counting. If you are wondering what reference counting is, then here is the answer. The Python interpreter always keeps a table where it counts the number of references to each object in the heap memory. The moment any object in the heap memory counts to 0, the interpreter declares it as the dead object, and then the garbage collector is invoked to clear it off. This kind of algorithm is called reference counting. This algorithm is helpful to keep memory utilization to its optimum, but it affects speed of execution, as the garbage collector is invoked frequently. Different programming languages use different garbage collection algorithms. For example, Java uses mark and sweep algorithm, where all the dead objects are marked initially, and a periodic invocation of garbage collection cleans it out. This type of algorithm is helpful to maintain high speed of execution, but it also leads to inefficient memory utilization. So both the algorithm has its pros and cons. I hope that the concept is clear. To keep the video length in control, I will give more examples in the next video, and explain memory utilization with classes and objects. If you like this video, then hit the like button, share it with other code lovers, and subscribe to the channel for more videos. Thanks for watching and happy learning.